Voltage and potential difference can be used interchangeably, but to understand what it is, it's better to refer to them as potential difference. Electric potential is the amount of work energy needed to move an electric charge from one point to another in an electric field. Potential difference across a distance in an electric field is the difference in electrical potential across a distance. Therefore, the voltage or potential difference can be represented by V equals W divided by Q. The unit of potential difference is 1V equals 1JC minus 1. Electromotive force. Electromotive force is the electrical action produced by a non-electrical source and is the work done by an electrical source to move one unit of charge in complete circuit. You may recall that potential difference also means something very similar, however there is a difference between them. Even though the units are same, the symbols representing them are not. EMF is represented with the symbol E instead of B. Electrical action produced by non-electrical source and work done by electrical source to move one unit of charge in complete circuit. But for simplicity's sake, the EMF or an electrical source is the full voltage of an electrical source. It will be easier if we compare the two. Electromotive force is measured by voltmeter in an open circuit. The voltmeter is connected across the cell terminals. No current flow in the circuit. A potential difference is measured by the voltmeter in closed circuit. The voltmeter is connected across the bulb and the cell. Current flows in the direction. The voltmeter will read the full voltage specified on the dry cell. The voltmeter will read a little lower than the dry cell specific voltage. Energy supplied by an electrical source to move a column of charge in a complete circuit. Energy supplied by an electrical source to move a column of charge between 2 points. Energy supplied by an electrical source to move a column of charge between 2 points. Energy supplied by an electrical source to move a column of charge between 2 points. One is supplied by electric move column of charge in complete circuit. One is column of charge between 2 points. The electromotive force of an electrical source is the potential difference across the source in an open circuit. This drop in potential difference compared to the electromotive force is due to the internal resistance of the dry cell. Similar to current, voltage can be measured by using a voltmeter. Notice that voltmeters are connected parallel to the circuit, while ammeter is connected in series. A perfect ammeter is an ammeter with zero resistance. A perfect voltmeter is a voltmeter with infinite resistance. The resistance of a conductor is a measure of the oppositions of an electric current when it flows through the conductor. Resistance is defined as the ratio of potential difference V across the conductor to the currents I flowing through it. The SI unit of resistance is ohms. Ohmic conductor and non-ohmic conductor. There are two types of conductor. We classify them based on whether or not they obey Ohm's law. If the conductor have linear relationship between currents and voltage, in other words, if V inversely proportional to I, It obeys its own laws and is an ohmic conductor. For non-ohmic conductor, the relationship between current and voltage is nonlinear. Look at the diagram. Series resistors, the current is the same for each resistor. The battery potential difference is the sum of potential difference across the resistors. Parallel, the sum of the currents entering a junction is equal to the current leaving a junction. The battery potential difference is the same as each of the resistors. So, if at the resistance 1 over parallel, then series is just pressed together. Resistivity of a wire, a material resistance is directly proportional to its length and inversely proportional to its cross-section area. When written as an equation, the resistance of material is R equals to P times L divided by A. Where P is the resistivity of the material of the unit of ohm, it is a constant specific to a type of material. For example, copper has a resistivity of 1.72 times 10 to the power negative 8. Wood has a resistivity of 3 times 10 to the power 15. There are three factors that could affect resistivity of a wire. They are length of wire, cross-sectional area, material type. So length. The longer the conductor, the larger the resistance. Cross-sectional area. The longer the cross-sectional area, the smaller the resistance. Then the longer the conductor, the larger the resistance. And then cross-sectional area, the longer the cross-sectional area, the smaller the resistance. Type of material. Conductors made from different materials have different resistance. Applications of resistivity of conductors in daily life. Heating elements. Heating elements in the catalyst made from nickel. It has high resistivity to generate large amount of heat. It has high melting point to withstand high temperature. Heating elements in a catalyst made from nickel. It has high resistivity to generate large amount of heat and has high melting point to withstand high temperature. Filament bulb. Filaments in bulbs are made of tungsten wires with low cross-sectional area and coil up to increase length. This makes the resistivity very high. Has high melting point to withstand high temperature. Can go up to 3000 K. Electric wiring at home. Common household wires are made of copper or occasionally aluminum. No choice of materials due to their low resistivity. This material also have high melting point to withstand high temperature. Electrical energy is widely used in our daily life because it can be easily converted to other forms of energy. Electrical energy to heat for cooking such as rice cooker, to sound energy for entertainment such as TV, to light, to mechanical energy for machines such as fan or washing machine. These electrical appliances requires electrical power to operate and is related to potential difference, current, and time. We learned that potential difference B equals E divided by Q, and current is the rate of charge flow. I equals Q divided by D. Rearranging these to give Q equals LD, E equals BQ, and E equals BLD. Electrical power is defined as the rate of electrical energy release or transfer. Power equals energy transfer divided by time. Substitute E equals BR2 into equation B 等于 BL_d2D， 所以 P 等于 BI. Therefore, power is the product between the potential difference and current. And then we can use Ohm's law B equals IR to change equation for power into other forms. Like B 等于 IR 嘛，所以 P 等于 BI 的话就等于 P 等于 I square R。然后 I 等于 B to R 嘛，所以 P 就等于 B 再乘 B to R， 所以 P 等于 B square to R。所以两个 P 等于 I square to R or P 等于 B square to R. I square are used to calculate power loss in electrical wiring system. B square to R used to calculate resistance of an electrical device from its power rating when functioning optimally. SI unit for power is joule per second, JS 减 EOW. Electrical energy in our house is measured in kWh. That means the amount of electrical energy that electrical appliance consumes. Example, an electrical kettle with a power rating of 1000 W is turned on for half an hour will consume 1 kW 乘 0.5 H equals 0.5 kWh of energy. The electrical energy company in our country, TNB, charges its customer based on the amount of electrical energy used based on the total kWh used per month.